Hey guys, welcome back. Today we are going to start our lesson on density. Now we're going to spend 2 days on density. Today we're just going to define it and learn what it is. And then tomorrow I'm going to teach you guys how to calculate density. So not doing any math today. Today we're just learning what it is. And then tomorrow we'll jump into those calculations. So today's pretty short, sweet, and to the point. So without further ado, let's go ahead and jump on in. All right, so in this course, we're going to need to understand the concept of density. And so by definition, density is the amount of mass per volume area. So the amount of mass per volume area. And another way of saying this is density is the amount of stuff in a particular space. So how much stuff fits into a defined volume. So why do we need to know density in physical science? Well, we've been talking about the differences between chemical and physical properties, right? This whole unit has been about matter. Density, if we remember, is a physical property. So it's a physical property of a substance. It does not depend on the amount of the substance present, so it's intensive. Remember when we talked about physical and chemical properties, if it's intensive, that means it doesn't change on the amount, based on the amount of the substance present. So intensive physical properties are density, things like pH, of that nature. Now remember, extensive physical properties do change based on the amount present. So that would be things like mass and volume. So the rules of density, a higher density means that there is more stuff in a space. So there's more particles tucked into a defined volume of space. A lower density means that there's less stuff in the space. So higher density, more stuff, lower density, less stuff. And here is a visual representation of how this looks. So we've got two boxes here, and they're both the same volume. So they're the same size. They can fit overall the same amount of stuff. So they're the same dimension. However, on the left-hand side, we've got way more of these particles inside the box. So we've got the green and the red particles inside. So we've got way more of those in the area. On the right-hand side, we still have some of those green and red particles, but there aren't nearly as many of them, okay? So on the left-hand side, so even though these boxes are the same size, they can hold the same volume, the left-hand side, those particles, that substance has a higher density because there's more stuff per space, okay? And then on the right-hand side, that's going to have a lower density because there's less stuff per space. And you guys can't see it, but I'm doing air quotes around stuff. Okay, so more stuff in the space, higher density. Less stuff in the space, lower density. So let's stop and pause and just think for a minute. We've got two jars here. So we've got jar A, which is packed to the brim with jelly beans. And it might be an unpopular opinion, but jelly beans are literally the worst candy. I think they're so gross. If you love jelly beans, that's totally fine. You do you, but I think jelly beans are so gross. But anyway, on the left-hand side, we've got jar A, where those jelly beans are packed to the very top. And on the right-hand side, we have jar B, where we've got some jelly beans in that jar, but there's definitely some space left. So if we imagine taking these jars and dumping them upside down, jar A, if we inverted it, those jelly beans really wouldn't go anywhere. Of course, unless, of course, we took the top off. But if you have your hand secure on the top and you invert it, those jelly beans are going to stay pretty much put because there's not much space in that jar. Those jelly beans are packing that jar and they're tightly packed in there. On the other hand, jar B, if you just were to take that and invert it and shake it around, those jelly beans would rattle around because there's more space available in the jar, and therefore that substance can rattle around and it can fill that extra volume. So therefore, jar A is going to have a higher density than jar B because jar A has more jelly beans per volume than jar B does. And we can also see this when it comes to things like liquids. So here we have a beaker that has 3 different substances in it. So we've got this brown, murky looking substance. This is the clear substance. And then we've got oil on the top. This is that yellow substance. So when we're taking a look at something like this, if we want to find the substance that is the most dense, you just have to look at the layers. And it's as easy as that. So the substances that have a higher density are always going to settle on the bottom. And then as you go up, those substances will have a lower density. So if we're looking at this particular picture, the substance with the highest density would be on the bottom. The middle would be the middle density. I'm assuming this is probably water. And then the oil on the top would have the lowest density, right? So it would be highest, middle, lowest. Okay, so high density equals sinking to the bottom. So substances that are the most dense will go to the bottom, and then substances that are the least dense will go to the top. Now I'll tell you guys right now, you'll have a test question and quiz questions where they'll either give you the density of a substance, like show you in numbers, like what is the density, or they'll show you pictures of the substance like this in a beaker where you have to tell me which substance has the highest density. And the way that you can tell, number one, if you're looking at numbers, it would just be the one with the highest number. And then if you're looking at something like this, a picture where the substances are settling out and have those defined layers, the ones on the bottom are the most dense, the ones on the top are the least dense. Okay. And then this is just another picture of that. So those substances, if they were labeled and you knew what these substances were, you could put them in order from most to least dense, because the ones on the bottom would be the most dense, and then the ones on the top would be the least dense. So you could basically put them in order from most to least dense, knowing that the highest density is on the bottom and the lowest density is on the top. Okay? And that's pretty much it for today. Remember, density is a physical property. It doesn't depend on how much of a substance there is, just what the substance is. And density is a measure of mass over volume, okay? And you guys should be able to tell me which substances have the higher or the lower density based on, number one, if you're looking at a picture, the highest will be on the bottom. Or number two, if you're given a set with the numbers, if it's a higher number, it just means a higher density. And that's it. If you guys have questions on that, be sure to let me know. And if not, we'll continue our lesson tomorrow talking about how to do the calculations, and we'll do a little bit of math. All right, I'll catch you guys in the next one.